The raptor dinosaurs, properly termed Dromaeosaurs, are everyone's favorites from the movies. Little do many know, they had more diversity in anatomy than the movies tend to make you think. Some were as large as the largest living crocs. Others were as small as crows. Some were skinny, some were thick, and others had huge hands. Mongolia seemed to be an epicenter for these dinosaurs, and a brand new one shows that their diversity only grows. I'm sure the first thing that comes to mind when you hear the name Mongolia is the dry, hot-cold desert wastes of the Gobi Desert. There is much more to Mongolia than just desert, but that's where all the fossils are found, so if you're a paleo nerd like me, and probably everyone watching, deserts tend to be the areas of the region that you care about. The Gobi Desert has been divulging secrets from all types of geologic periods and epochs for quite a long time. Well, on a human timescale anyways. Out of the Cretaceous sediments have come all sorts of mammals, reptiles, fish, plants, invertebrates, and of course, dinosaurs. Armored ankylosaurs, terrifying tyrannosaurs, towering titanosaurs, pickaxe-handed alvarezsaurs, parrot-beaked oviraptorosaurs, among so many other groups. Aside from the oviraptorosaurs, it seems one of the commonest groups was the Dromaeosaurs. They just keep being found throughout Asia, but especially Mongolia, and the bits of Mongolia that are technically China. And yet, some of us paleo nerds that do not have eagle eyes may be unable to spot major differences among these raptors. One new critter goes to show there's more to them than meets the eye. Though there are plenty of new expeditions to Mongolia, resulting in the discovery of all sorts of new and cool things, there are also a ton of fossils that have already been found on expeditions of decades past. They remain in local museums and institutions waiting for preparation and description. Plus, many were taken out of Mongolia, and therefore must be returned, sometimes before any science can be done on them, though this is not so much the case these days since many paleontologists collaborate with their Mongolian colleagues. The American Museum of Natural History of New York had taken some expeditions to Mongolia in the 1920s and 30s, but didn't get back out there until the 1990s. In the midst of July 1991, during the first of the recent Mongolian expeditions, paleontologist Dr. Mark Norell found the nearly complete skeleton of a very handsome raptor dinosaur. This specimen would remain mostly undescribed for 30 years. Though it was given the nickname of Ichabod Craniusaurus due to lacking a skull, it would be lumped into the world-renowned Velociraptor mongoliensis species in many books published in the late 1990s. 2021 finally saw this specimen fully described by Alan Turner, Shayna Montanari, and Mark Norell as Shri devi, which is the name of a wrathful Buddhist god. This holotype specimen, MPCD 100/980, was a nearly complete spinal column with much of the hips and an entire leg. The only thing it's missing is the noggin, 2/3 of the other leg, the arms and shoulders, and the end of the tail. From this, though, the team of researchers were able to find that Shri was the closest known relative of Velociraptor and may have looked a lot like it. The parts of the skeleton they had were indeed quite similar to the same parts in Velociraptor. Then, in 2023, a paper was published by Lukasz Czapinski describing another Dromaeosaur specimen that was discovered in 1970 by Polish and Mongolian scientists. This specimen consists simply of a chunk of skull and jaw, plus the entire left foot and the lowermost part of the calf. Apparently, enough anatomical traits were preserved in these remains and the admittedly little overlap with the 1991 specimen for Czapinski to hypothesize that they belong to the same animal. So, the noggin had actually been found. Ichabod Craniusaurus is headless no more. Well, maybe, probably even. Both of these Shri devi specimens come from the Kulsan locality of the Barungoyot Formation. a stratum of rock dating roughly to the Maastrichtian stage of the late Cretaceous epoch around 72 to 71 million years ago. But there's always some discussion going on about exactly how old it is due to the difficulty in reading and measuring the layers between layers, since everything is just a mess of sandstone. While all of this was going on, yet another Dromaeosaur skeleton was floating around private collections waiting to be snapped up by someone who cares about science. Prior to 2010, the nearly complete skeleton of a small Dromaeosaurian theropod dinosaur was discovered and poached from somewhere in the Gobi Desert. After the poaching, it was sold to a private buyer, and it changed hands between people in Japan and Europe before being bought once again by the French fossil and cast company Eldonia. The director of this company, François Escuyer, should be recognizable by now since he was responsible for the organization of the acquisition of the Dinocyrus paratype skeletons and Velociraptor holotype. By 2016, the specimen, which included the entire skeleton, missing only the tip of the snout, some of the backbones connecting the torso to the hips, the very tip of the tail, the lower parts of both legs, and the left arm, was taken to the Royal Belgian Institute of Natural Sciences to get CT scanned. Once scanned, it was unfortunately returned to its owner. I say this because the skull and the first 4 neck vertebrae that went with it are now lost. Since all known Mongolian specimens have to be legally repatriated back to Mongolia, this specimen was also returned, but the head got lost at some point between CT scanning and its repatriation, and no one seems to know how or why or where. Considering the exponential increase in dinosaur prices, it could be anyone. Eldonia? A worker at Eldonia? A FedEx or Amazon worker? Anyone at the Royal Belgian Institute of Natural Sciences? Or simply a shipping error? Anyone. Regardless, the specimen was fully described in 2025 by Léa Motrier, Andrea Gao, Sogbatar Chinzarig, François Escuyer, Kashikjev Sogbatar, Bayaska, Gonzarig, Christoph Mallet, and Pascal Godefroy in the journal Historical Biology, and given a new item number, MPCD 102/117. Thankfully, those CT scans allowed this team to 3D print the missing skull and include it in their description. However, because the whereabouts of the skull are currently unknown, they had to exclude any data from the skull from analyses they conducted on the evolutionary relationships of the skeleton and the full list of characters used to separate it from any other dromaeosaur. Speaking of which, the thing is a new species. Unusually for dinosaurs, this specimen preserves enough anatomical information that the team found it was a second species of an already known genus. That old Shri from 2021 and 2023. So they named the new critter Shri rapax, with the species name being a Latinized form of rapacious. Shri rapax is suggested to originate from a slightly different stratum than Shri devi. The exact locality cannot be known since it was stolen from the Mongolians, but based on the sediment stuck to the bones, the bone color, and the type of dinosaur Shri rapax is, the author team hypothesized the most plausible place of origin would be the Ukha-Tolgod locality and the Jadokta Formation, which is the Campanian age of the late Cretaceous epoch. This makes Shri rapax slightly older than Shri devi. The most striking thing about Shri rapax, aside from the amazingly preserved gastral basket, this whole complex of ribs, chest plates, and more ribs here, is the hand and the skull. Since we don't have a noggin, why don't we take a gander at the hand first? So, it may not look like it much from this photo and point of view, but the hand of Shri rapax was large. I mean, like disproportionately large.
And you know what they say about men with small hands?
The researchers found that each bony chunk of the thumb, or digit 1, were about 150% larger than the same bones in the hands of the other dromaeosaurs of the time and region of Shri rapax. They say that the bones are stouter than in any other dromaeosaur, and that the bit at the bottom of the claw that attaches to tendons for flexing the claw and the finger is big and rough, which means the animal would have been able to flex the claw down very tightly. The claw itself is quite curvy and said to be proportionally or outright longer than the same claw in any other dromaeosaurid in the region and time. Interestingly, the forelimb is actually small. The research team compared the bones in the forearm with those in Deinonychus and found them to be around 64% smaller, but the hand itself was around the same size. It had short arms but big hands and claws. So, what the heck, right? What was it doing with those big ol' slappers? The researchers hypothesized that Shri rapax had such large hands to help it procure a
succulent Chinese meal.
That is, it seemed that these dromaeosaurs used their hands a lot when grappling with their prey. One of the very few specimens that is more or less unambiguously showing an interaction between predator and prey, the Mongolian fighting dinosaurs, preserves the fatal fight between a Velociraptor and Protoceratops. However, more relevant to Shri, the Velociraptor's left hand is grabbing at the Protoceratops's face, while the shelf head has the raptor's right hand in its mouth. Presumably, the arms were dangerous enough to be a priority in disabling in self-defense. Almost all dromaeosaurs had very mobile hand joints, so they could fold up their arms far more than most other theropods. They had very flexible finger and claw joints with lots of tendons and quite a large range of motion in the shoulders, all of which points to the strong likelihood that these animals used their arms as primary or secondary weapons for nabbing some munchies. Perhaps the enlargement of the hand and claws seen in Shri rapax indicate an evolutionary trend towards taking down the nastier prey, Neoceratopsians and Ankylosaurs. Aiding this interpretation is the snout, which I think we can now take a gander at. Yes, the skull is missing, however, the author team does have a highly detailed CT scan of the skull and neck, a cast made of the whole thing before it was lost, and have 3D printed the skull from the scans. So, even though they cannot really use any of the data from the skull for defining the species of Shri rapax in any meaningful scientific way, they can still describe the skull anatomy as it relates to what the animal may have been adapted for. As you can see, the skull seems quite robust. Let's compare it to the few skull bits of Shri devi. They look quite distinct from one another. I wouldn't be entirely surprised if other groups of authors would have called Shri rapax a new genus of dromaeosaur, rather than a species of an already known genus. The authors do talk about this in their paper. They note that the stratigraphy of the area, or the way in which the rock layers are organized, reflects a more complex system than the usual younger and older beds laying atop one another. By that I mean that there aren't a lot of very obvious or strong layering going on, and it's all a bunch of generally structureless red sandstones with some blobs of conglomeratic stuff every so often. It may be that the different formations in the region, your Nemegt, Baranguyot, Jojokta, etc., are separated a little bit in time, but are much more strongly separated by environmental conditions. Some were dune-like environments, others marshier, others more floodplainy. As such, all the different dromaeosaur genera known from the region are closer together in time than their physical distance from one another might suggest. They don't bother doing any revisions of the obscure and fragmentary species Velociraptor osmolske, but note that a total revision of Velociraptor to include species that are currently considered separate genera, Linoraptor, Shri, and Sagon, would fit with what is known of the rock layers. The other major thing that sets Shri rapax apart from its cousin is that it had a robust skull. The very tip of the snout, a pair of bones called the premaxillae, are missing. It's possible that the full skull was longer and made it seem slightly less robust, but even then, the skull would be thicker than most other raptors of the time and place, which all had quite skinny snoots. A robust skull is usually much better at delivering a stronger bite and is more resistant to stress and strain. Perhaps the big hands worked in tandem with the heavy skull and jaws to exploit an ecological niche that the other dromaeosaurs were not, taking on bigger, more aggressive, or more protected prey items. This is what the author team goes with. It's called niche partitioning. It explains that a bunch of species of the same groups of animals can coexist if they all eat different things. It halfway explains why the Serengeti has so many cats or why the Morrison Formation is choking on sauropods. But only halfway. The true level of biodiversity that any given ecosystem, living or extinct, can take is hard to grasp even with as much data as we have today on our own, still living ecosystems. After all, we currently live in a biologically impoverished time. Several extinction events, man-made and natural, have occurred and are currently occurring. Raptor Chatter, a great channel you should check out when you get the chance, has published a video talking about how some paleontologists might be relying too heavily on the concept of niche partitioning to explain differences seen in fossil animals. Ezekiel Callahan explains that in modern ecosystems, which we should not assume worked entirely differently to those of the past, there are a bunch of predators that overlap in prey items. They eat the same types of prey animals, even if they have different adaptations that allow them to be better at hunting specific types of prey. Coyotes, wolves, cougars, and bears will all eat deer, rabbits, and fish if or when they get the chance. Maybe this means niche partitioning isn't that strong of a factor in the evolution of novel body parts or body plans, but it still exists and still has some pressure in the evolution of animals. Despite its skull and hand differences to Shri devi and other raptors it lived with or near, the author team collected enough data from the skeleton to figure out what it was related to and why it was a species of a known genus rather than a new genus. They collected anatomical traits, turned that into numerical data, put that data into a phylogenetic software, and had that data fight with the data of already known dromaeosaurs. Out of the various analyses, the one that had the highest accuracy placed this new dromaeosaur as the direct sister to Shri devi. Shri devi and Shri rapax act as a small group that split from a common ancestor with Velociraptor mongoliensis. This grouping is most closely related to a grouping that includes Velociraptor osmolske as the basalmost member and Saugon and Linharaptor as the diverging pair group. All of these dromaeosaurs are part of the group Velociraptorinae as part of the greater Eudromaeosauria. Wait a minute, so how can a separate species of Velociraptor not be the most closely related cousin of the other species of Velociraptor? Well, that brings us back to what the authors were talking about with Velociraptor osmolske. It's just some skull bits, so it doesn't really tell you much about it, and isn't the best specimen to place into a phylogenetic framework like this. Hence why the authors who described Shri rapax didn't really want to do too much with it. I mean, I think it's possible that the common ancestor that led to these two groups was basically an ancient form of Velociraptor. Obviously, the naming and taxonomy wouldn't make sense to call it a Velociraptor, but it would probably not look too different from them. This could then mean that the other dromaeosaurs here that are given distinct genus names would have evolved from Velociraptor-like ancestors. This is sort of why there is some talk amongst academics of lumping all these dinosaurs together as species of Velociraptor to preserve a natural grouping, or just, I don't know, maybe wait for some dromaeosaur material to be named, rock strata to be redated or organized, or some other thing. I think it's high time I move on from what this thing is related to and what it may have been doing with those mittens. I've already given the game away on how complex the rocks are in this region of the world, so it's a little difficult to be absolutely certain of which dinosaurs lived alongside Shri rapax. Especially what with the whole poaching thing, but you can kinda assume the critters found in the same locality from the exact same horizons, if you can even call them that, would probably have been contemporaneous with the
rapacious rat bastard.
However, before I do that, let me just bring in Mr. Man from Animal Planet's
The Most Extreme
real quick, to give you a sense of scale. Shri rapax wasn't much different in size to all of its other raptor compatriots, being a little less than a meter tall and around 2 meters long. No, not giving you American numbers for this one. You get to fend for yourselves. I was eyeballing the estimates anyways. Thanks, Mr. Man. Uka Tolgod is the locality the authors narrowed down as the most likely origin place of Shri rapax. This locality is known particularly for producing extremely well-preserved and almost complete specimens of all sorts of animals, but most importantly, skeletons of medium to large vertebrates. That's rare, but also rare in this particular way and in this particular region. Some fluvial sediments exist at Ulkal-Tolgod, indicating there were rivers snaking their way through the region during the late Cretaceous. However, other rock sections are made up of huge unbroken sandstones, the kind of stuff left by dunes in an arid desert environment. So, the fluvial sediment may have been brought into the area during monsoonal seasons, before they quickly dried up and were dominated by the dune or aeolian depositional environment. As for dinosaurs, Shri rapax may have lived at the same general time and place as the small, possibly semi-aquatic Velociraptor, the very Velociraptor-like Sagan, and of course, Velociraptor mongoliensis itself. Paleoartist Hodari Nundu has depicted a fight between Shri rapax and Velociraptor mongoliensis, pitting the two against one another as natural arch-nemeses. Though animals don't do that obviously, the relationship was too good for people not to pick up and run with, including myself, unless I've changed the title or thumbnail a bunch since this video first published. Anyways, the heavier hands and face of Shri rapax may have made it a nastier foe for Velociraptor, but fights between animals tend to be relatively rare, and something like this may not have happened often. Then again, we see in today's North American southwestern and montane ecosystems that wolves tend to take any opportunity to hunt down and eat coyotes. Some explanations for this ecological interaction involve the wolf's more complex social behaviors and an overlap in prey items and habitat preferences. That's the niche partitioning thing again, and yet wolves don't usually totally extirpate coyotes from regions they enter or live in long term. Though one readily hunts the other, and though both overlap a lot in prey items, they both live together frequently. Anyways, let's do some sightseeing in Cretaceous Ulkal-Tolgod to see some non-raptors. Larger than the raptors were the ostrich dinosaurs like Apiornithomimus, which used its long, springy legs to carry it across the ground at a rapid pace, or to kick unwanted rapacious predators. It and the raptors were joined by tyrannosaurs, though no remains have been collected or described that are good enough to slap with a scientific label yet. One of the more common groups of theropods were the parrot dinosaurs, or Oviraptorosaurs. The ones at Ulkal-Tolgod include Avimimus, Citipati, and Con. On the other side of the Paraves tree was the Troodontidae, usually considered the slimmer, smarter, more nocturnal cousins of the Dromaeosaurs. They were represented at Ulkal-Tolgod by Almas, Byronosaurus, and various juvenile to adult remains that have yet to be classified. Flying above them were avian theropods, such as the ornithurine Apsaravis and the enantiornithine Gobiturix. The bizarre, possibly insectivorous owl-like Alvarezsaurs have been found here too, such as Cole and Shibuya. Sauropod dinosaurs would have lived in the region, but their fossil record remains spotty for now. As for hornheads, there are several skulls and post-cranial remains known, but not yet classified beyond Protoceratopsidae. The mighty club tanks were represented by Minotaurosaurus and Pinacosaurus, some of the boniest and encrusted-looking turtle pigs known to science. I wouldn't only touch on the dinosaurs, since I'm not just a dinosaur guy. The place had turtles like Zangurlia, therian mammals like Eucotherium, Melestes, Canelestes, Hyotheridium, and Deltatheridium. Multituberculate mammals such as Tombatar, Sloanbatar, Nemegbatar, Cryptobatar, Camptobatar, Pulsanbatar, Katopsbatar, and Bulgonbatar. The place was either crawling with little mammals, or the unique environmental conditions were perfect enough to preserve the mammal diversity that was universal throughout Cretaceous Mongolia. Probably that last one, because lizards are here plenty too, like the Teiids, Adamisaurus, Gobinatus, Tuchingisaurus, and Macrocephalosaurus. The Veranoids, Aeolosaurus, Shermanotus, and Ovu. The weirdo Carusia, the Skinks, Eozenta, Globara, Parmiosaurus, Slavoia, and Hymenosaurus. Monstersaurs, Estesia, and Gobiderma. The Iguanians, Isodontosaurus, Saichengurvel, and Temugenia. Acrodonts, Mimeosaurus, and Phrynosemimus. Gecko, Myrmecadaptria, and the large Priscagama. Wow, lots of lizards. These short-skulled Shamasuchus may have stuck to hard-shelled invertebrates in those ephemeral lakes and ponds. Even just this one locality was flourishing with all manner of life, so I believe this points to many other Cretaceous Mongolian localities probably also containing as much life, and they just didn't get fossilized. Imagine the life of the Shri rapax leading to its death. Its body was mostly intact, so that implies it may have died similarly to the fighting dinosaurs, covered by a dune. Or perhaps it died quietly and peacefully, only for its body to eventually get covered by a dune. Perhaps it had gotten one last hunt in before the end. Perhaps not. Either way, its remains have gone on to help us understand the ecological interaction of this ancient ecosystem better. Unfortunately, the only way to get an even better handle on that is for more remains to be found. Or at the very least, that stolen or lost head to be found. Hopefully someday.
For more interesting stories about nature, the history of life, or what goes bump in the night, subscribe, like this video, drop a comment in the comment section below, and hit the bell icon to stay in the know with everything Edge. Thanks for watching.